All right, well, welcome everyone. I've started recording, so just to keep in mind that you are being recorded. Um, my name is Liz Hoy, and I work in the NASA Carbon Cycle and Ecosystems Office, and I help to support the Above campaign. And we have partnered with the NASA Center for Climate Simulation to develop a high performance computing environment, and we call that the Above Science Cloud. It's hosted on an environment called ADAPT that NCCS has developed, which is the Advanced Data and Analytics Platform. There aren't too many of us on here, but I'm just going to go through. I have a few slides to kind of give some introductory material about what is the Science Cloud and what resources are available to Above users on the Science Cloud. And then we have members from NCCS on the call. I think I see, let's see, Jim Shute, Laura Carrier, Matt Stroud, Mark Carroll, Ryan Forbes, and I think Ellen Salmon as well. So we have quite a large group from the Science Cloud, from NCCS and SISTO here, who are familiar with all of the systems that they have available. And so I might kind of pass the mic to them at certain points and they can answer questions that people have or provide more details that maybe I'm not aware of. So if something comes up or if you have a question, please feel free to type it in the chat, or I think you can raise your hand on here. We'll just try to, there aren't so many of us that we have to keep this really formal. So if you have a question as we're going through, you can feel free to ask it, or you can hold it and we'll go over it at the end. Okay, so we'll go ahead and get started. Let me hide my speaker view and my recording because I can't see anything. Okay, so the Above Science Cloud is, as I said, it's on ADAPT, so you'll hear that a lot. We use those terms almost interchangeably. ADAPT is the larger system, and the Above Science Cloud is kind of like a small part of that. There are Linux and Windows virtual machines, and there are some large staged data sets that are available for everyone to use, and there are some that are restricted, and I'll go through them a little bit. If you ever want to learn more, I've got a link down at the bottom that talks about the ADAPT system itself, and there are a lot of links from there that are really useful as well. So I wanted to just start off with what is the Linux VM? These are kind of a command line interface where you can go in and there are these different nodes where you could submit jobs and run them on the high performance compute system that's available, which is next to the storage system. So we have these above nodes, above 101 through 103, and these are really depreciated nodes that are being upgraded to CentOS 7. And then there are these above 101 through 110 nodes that are being upgraded. You submit jobs via Slurm, and there is a connection also to the above Jupyter Hub instance, and I'll just mention a little bit more about Jupyter Hub later on. This particular Jupyter Hub is only available to above users that are on the NASA VPN network, which isn't very many of you, but there is another Jupyter Hub that's available for those of you not on VPN. And the agency is starting to change who can access VPN. So in the next few months, there might be opportunities for non-NASA VPN users to somehow access the VPN and use this service. So we'll keep you guys updated about that. And then there's this Above X 101, which is a dedicated data transfer node. There's a link at the bottom, which if you go there, it'll show you how you actually access the Linux VPN nodes, and you can always contact the NCCS support group and they can help you to access it. But really, ideally, you're submitting jobs via Slurm, and I think there's some tutorials online from NCCS about using Slurm as well. And we can ask Matt at the end too. The Windows VMs, this system functions almost exactly like a normal Windows PC. So there's a web interface where you log into basically a Windows PC and you're just you're remote connecting and you're viewing an image of a PC. And this can be really helpful to use ArcMap products or ArcPro Esri products because it's difficult to use. You can't really use them on the Linux side. You could use QGIS on the Linux side, but in the Windows VM, you have this nice interface where you can use ARC products or Esri products. You have about 1 terabyte in your C drive, but then you can also link to your home space and your no backup space, and it's shared between both the Linux and the Windows systems. It's connected to all the other shared file systems as well. So I have an intern that I'm working on a project with, and we have a shared space where we were both able to access the data sets, and we can both log into our Windows VMs, and we can kind of work independently or together because the data is all staged in the same space. So that's really convenient for us. There's a lot of information about how to log on to these systems, and I've listed it here. If you're using the Windows VMs, you're going to use this web interface called Guacamole, and you have to type in some passwords. If you get stuck, you can always talk with support at nccs.nasa.gov, because I know that can get a little frustrating sometimes if you're getting stuck. There is a video that's on the NCCS site which explains a little bit about how to get online. So if you have trouble, watch the video, or you can contact me or contact NCCS support. This is new since we had our last webinar. We have many different data sets that are staged in what they call the CSS, the centralized storage system. That might not be what the third S is, but there's the CSS system, and there are many data sets that are already available for people to use here. I'll talk about 2 of them in the next few slides. So this above data set that has 80 terabytes, and also the last one on the list, the NGA data set, which is 4.5 petabytes. I think it's actually larger now. But there are others here as well. We've got like I think the ICESat is really useful, Landsat, MIAC, MERA, all of those data sets can be really useful for folks, and they're already there and they're already staged. So you don't have to go and download them, they're just already there. I want to mention this, we call it the NGA, which stands for National Geospatial Intelligence Agency data set. It's the Digital Globe data set as well, and Digital Globe was purchased by Maxar, so it's really now the Digital Globe / Maxar data set on ADAPT. So this is a collection of very high resolution imagery. The imagery resolution is about 50 centimeters or a meter. So it's really high resolution imagery that's available on the Science Cloud and or available on ADAPT. This is only available if you have a signed NASA NGA form, and you're only given access to particular zones of imagery based on what your NASA-funded project is. So you need to be a NASA-funded researcher working with a NASA-funded researcher to be able to.
And initially we asked that users not download anything out of the cloud, to use it on the system, and then to download a product that we created. But
Hey Liz, something just happened to your audio.
Can you guys hear me?
Sounds like you're in a can. There you go.
Better now.
That came back.
Okay.
Yeah.
All right, thanks. No one ever knows. This is working from home thing. So this imagery is only available for those who have requested it and been granted permission. And there are nuances about access. If you need to share this information in a publication or in a presentation, you have to receive permission from NGA first. But I did want to show kind of how much imagery we have. So the catalog itself, if you look at the bottom imagery, the map, you can see that there's a huge collection of imagery that's available. And I'm not sure why that line is in there. I think that's just something with the database that's showing that long line that kind of goes across the circumpolar region. But what I'm trying to show here is that there is a very large collection of imagery spanning the entire globe. And you'll see that it's kind of a bit more filled in the above domain. And the top graphic is showing what's available in the above domain. And right there, you can see that we're still currently receiving imagery for the above domain. So 2020, we've got a lot of imagery there, hundreds of terabytes. And then 2021, we've got almost 150 terabytes that have been added in for 2021. And this, of course, I think I got these numbers in September. So we still have a good portion of the year left to go. And overall, you can see that the cumulative number of images that we've received for the above domain over time has really increased dramatically. So we are getting new images, and then if there are areas that you're particularly interested in and you find that they're not on the ADAPT already, you can work with me and I can help to have those images transferred to the Science Cloud. I just need your catalog ID for that, for the catalog IDs you're interested in. So 19.3 million images, so I've got quite a lot. It's my dog. Okay, I also wanted to say that we have this above archive data from NASA archive centers that's already staged for everyone to use on the Science Cloud. And this is data coming from the Oak Ridge National Labs DAC, which is the biogeochemical DAC that DAC is Distributed Active Archive Center. So this is where most of our above data sets go. Right now we have 134 data sets from the above campaign archived at that DAC, and they are all mirrored on the Science Cloud. Then we also have the Elvis imagery, which is a LiDAR instrument, and that's coming from the National Snow and Ice Data Center, NSIDC. That's on ADAPT. And then also we have some L-band UAV SAR data that's coming from the Alaska Satellite Facility. And so those three kind of collections are at the top, just to show you what we have. And then down on the bottom of the slide shows you where you could actually access this data. So if you're on the Linux VM, you go to CSS/above, and you'll see that we have these kind of four locations in blue. They're not necessarily very, very pretty to look at, but it's this Avarice Analysis Ready Data product is a product that we had a group kind of help us to put together. But then the three large collections are this dac.ornl.gov, and that's, of course, the ORNL DAC data sets. And then we have this datapool.asf, and that's the L-band data. And then we have this NSIDC data, which is the Elvis data. So that's where you would find it if you're looking on the Linux system. And then if you're looking on the Windows system, this is what it actually looks like in MOBA Xterm when you open it. But essentially you'd be able to type in CSS/above/data, and you could pull this up. And just wanted to show again that it's not necessarily, the easiest folders names to look at, but if you read through them just a little bit, you'll see one says ORNL, one says NSIDC, and one says ASF. And then there is also that Avarice data, which is another hyperspectral instrument, and we've one of our groups has created kind of an analysis ready product of that, and that's available for people there as well.
Hey Liz, before you go
Yeah.
on, can I ask a quick question on
Sure.
that previous slide? So Mark Carroll was asking about Avarice data. Is this the data that he would need, or Mark, do you need another data set?
So the issue there, Jim, is that Matt Stroud he does the ingest of any of the Avarice data. He's mirroring what comes from Oak Ridge, but it comes in a format that's not usable for anyone. And we added a step to be able to turn it into this analysis ready. What we were trying to do in that ticket was to add that step to Matt's ingest process, so that it happens automatically rather than somebody having to initiate it at some later time.
Okay. All right. So the stuff that's in that directory is good, but any new stuff would need to go through this extra step. Did I hear that correctly?
The stuff that's in there is good, but it's incomplete. There's things in the Avarice directory that are not in the Avarice Analysis Ready directory because it hasn't gone through the step to do that.
Okay. All right. Thanks.
So this is something we're kind of constantly working on, is we're able to put intermediate data products or data products that investigators have updated or changed. We can stage them here on the Science Cloud too for the rest of the use of the other Science Cloud or the Science team members. And so that's what has happened with this Avarice data, is that we've noticed that it can be very difficult for some investigators to use in certain programs. So I think Mark Carroll and his team have worked to kind of update the format and change some of the header information to make it a little bit easier to use. But we're always constantly looking at ways that we can expand on that or make other products more easily to use as well. We also have these Esri capabilities on Adapt. So as I mentioned, we do have many licenses available for ArcMap or ArcPro on the Windows VMs, and you can just log in and use those. We also have this Esri GIS portal, and we have these Arc Server applications. So if you have a project where you want to share something out with the group, or you want to create a web map or some kind of web services, we have the capabilities to do that. And for example, the NASA landslides team, they coordinate, they're kind of more of an applications group, and they're working on kind of identifying landslides around the world and providing information about them and letting people around the world know where landslides are. They're using this GIS portal, this web services portal, to provide information out. And so that is available, and you can go to that maps.nccs.nasa.gov site and check out what's already there and think about whether your project could benefit from using something like that. I don't know, Jim or Ryan, if you wanted to say anything else about that before I move on.
Well, if you want, I can go into a little bit more detail about what the server can do.
Yeah, go for it.
Sure. So I think something I'd want to highlight. We have the machines that power these servers are very powerful, and we have two dedicated image servers that work very well for not only sharing imagery across the web, but also they have the capability to do some analysis as well on the back end. And then the next one I'd mention is we have a dedicated geoprocessing server, which is equally as powerful, if not a little bit more powerful, I believe, than the image servers, that is capable of performing analysis on vector data sets. So the stuff is out there and is available for use if it fits into anyone's workflows.
Thanks. Awesome. I also wanted to mention, because I don't always think that Above Science team members remember this, is that Above does have an allocation on the Discover supercomputer. This is something that I requested a few years ago, and now we have it as just an allocation that's available for Above users if they think that they have processing that might be better suited for the Discover system versus Adapt. So this might be something where in Adapt, you have maybe a lot of input data sets and maybe just one kind of output, but maybe on Discover, you're running a lot of code to generate a model, or you're generating a lot of output data, or you need some parallel processing capabilities. You might need to move to Discover versus the Adapt environment. And we do have a project there that you can use to test out what you think you need. And then you can use it for kind of that first year as you're testing things out. And then when the cycle comes for you to request your own allocation, you'd be able to actually allocate your own, or request your own allocation for your project. So if you're interested in using kind of the allocation we have, just contact me and I can help you get set up with that. I can help you. If you already have an Adapt account, it's not too much more to add a Discover account to that. And we can get you set up so you can start using that system as well. And what's great is that the CSS data storage system is available on both Adapt and Discover, so you can have data stored in one place and use it on both sides. There's also this new Prism cluster, and it stands for something cool. I can't remember how they found a name for that, but it's, I don't know, Mark, maybe you can put it in the chat. But it's a GPU cluster that's available, 22 nodes each, with NVIDIA GPUs with 32 gigabytes of VRAM and 20 Intel CPU cores, and so you can read all about it. But so that is also something that's available. It's great for doing kind of machine learning or AI work. And if you need help with that, Mark Carroll kind of think helps quite a bit with getting that set up for people. Or setup would be through NCCS support, but then if you have questions about it. Oh yeah, so Jim's posted. Oh, now it's gone away. Let's see. PRISM stands for Promoting Research and Science Using Machine Learning. So that's what PRISM stands for. So if you're interested in using that GPU cluster, you can email me or you can email support at nccs.nasa.gov, and they can help you get set up with that. So we mentioned a little bit earlier that Jupyter Hub is now available. And this is a little tricky. So Above does have its own Jupyter Hub instance. However, you have to be on the NASA VPN to use that particular instance on the Above nodes. And that's just due to some security issues that NCCS is still working through. But then NCCS also has another Jupyter Hub account or another Jupyter Hub instance that's available for Prism. So the primary use then is for Prism users who want to use the GPUs. However, it can also be accessible for others in the Above team if you can't get onto the Above instance of the Jupyter Hub, but you really want to test out Jupyter Hub with your work. So we are still trying to scope how we can have non-NASA VPN people on the Above Jupyter Hub, but NASA's been changing some of the rules about that a little bit. So we hope to have that in the next few months. But for now, you could, as long as space is available, use the Jupyter Hub that's available on Prism. So this is most of what I wanted to present, and I just wanted to give an overview of some of the systems and capabilities that are available because they've changed some since our last webinar, and it's been a while, so I wanted people to know what we've got here. So I just have a few updates, and then maybe if there's time or questions, Matt has some tips and tricks he can share with you, and we have some other questions. We can answer those as well. So I just wanted to let people know Adapt does have scheduled downtimes, and it's strange. It's not the same time every month. It's monthly, the Wednesday after the second Tuesday of the month. So in the next 2 months, it's October 13th and then November 10th. And then I just also wanted to mention that NCCS is moving to the Explorer system, where new hardware is going to be coming in the next few months to kind of help with some file stability issues and some other issues that the NCCS team has been working on. So you'll see more. There are support messages that come out pretty frequently. I know recently my spam filter started to think that the NCCS messages were junk mail, so you might have to keep an eye out in your junk mail folders. But I think that was just for NASA people, and I think it's actually fixed now. Peter says, did I miss a mention of the stereo pairs and DEMs? So along with this digital globe imagery back here, a lot of this imagery is stereo imagery, which can then be used to create digital elevation models. And in some cases, we've actually created some digital elevation models. We've done that for areas of the Above domain, and that's available for NASA-funded scientists to use on the Science Cloud. There's also another Above team that has worked to create kind of an Above DEM. And I think that he has that staged on the Science Cloud, although he hasn't finished that data set up and published it yet, but I think that's something he's planning on doing. So if you're interested in using some of the elevation products that are available, you can reach out to me and I can put you in touch with where you can find them on the Science Cloud. You see another question in here from Melissa. Is the NGA database Maxar data listed under its catalog ID? How can I search for a specific image, latitude and longitude? So there is actually a database. There's a footprints geodatabase that's on the Science Cloud, and I didn't put the link in this PowerPoint because I believe in the past they've asked me not to share it out on these presentations since I post them on the web. But Melissa, I can email you afterwards and give you the link to where you can access the Digital Globe Footprints database on the Science Cloud. And with that geodatabase, you can search for individual catalog IDs. The file structure is such that it goes, I think, by sensor type, and then I think it's year and then day in the year. And so that's kind of how the file structure goes on the Science Cloud. But what I would suggest you do now is I can give you the location of the footprints file, which shows the geodatabase of all the locations of all the images, and then you can kind of run a search query to see the area you're looking at and what type of imagery, if you want stereo imagery or recent imagery or past imagery. And so I can send you that. Okay. And then if we have other questions, you can go ahead and ask those. I think the only other announcement I wanted to make is that if you're already using the Science Cloud and you want to tell the rest of the group about how you're using it, I always like to have little mini presentations where people can share. You could just do 10 minutes of what you're doing on the Science Cloud and how it's working and what you're running. I think that's always really useful for other people to see how they can apply it in their own research. And then as a reminder, if you're going to publish data or publish a data set using the Science Cloud, to make sure you incorporate some language that references above and references the NASA High-End Computing Program. So that box in blue is how you should be making sure that you're acknowledging your work on here. Okay, I've reached the end of my presentation here, and I can do, if we have any questions, we can go ahead with those. So you can just unmute yourself and ask, or you can type it in the chat. Here we go. Darko asks, sometimes I experience connection drops in Guacamole. Is this normal, or could it be due to my internet at home? So I can say, Darko, I'm curious to see if it's been happening for you in the last week. There was an issue with Guacamole, and every 3 minutes after the hour and every 33 minutes after the hour, there was a kind of a network switch that was timing out and causing everyone to drop off of Guacamole and then have to reconnect. But they did fix that, and so I know with the last week for me, it's been working well. Okay, yeah, Darko says it seems to improve this week. So that was a big issue that was happening for everyone. I do have one intern still who I just talked with her this morning, and she's still having trouble with her connection, and it could be an internet issue, just what bandwidth she has available at home. But I know that 3 minute and 33 minute after the hour, I think they fixed that. All right, any other questions? All right. Well, here we go. Here's one. So Mark Tapping says, logging into Windows VMs via Guacamole, file systems sometimes just disappear. Any chance of automatic weekly backups? And this is a question I think maybe I'll let someone from NCCS answer. Sometimes it can be very slow to connect to the shared file systems, but I think that you guys have some hardware that's going to work on that. I would say, Mark, you want to make sure that when you're saving data, when you're working on Guacamole, you're not saving data to your desktop. Make sure you're saving it either to your no backup space or your home space, because that's where kind of your backup is more or less. Because the Windows VM itself, you might log into a different VM depending on which day you log into the Science Cloud. So you don't ever want to save it on the C drive. You should really be saving it to the home space or the no backup space. But I don't know, someone from the Science Cloud, if you want to maybe talk a little bit about system stability and file systems.
Yeah, this is Jim Shute. I'll say something to that. So I do want to reiterate that while you can use that local drive on the Windows VMs for kind of intermediate work, we wouldn't want you to store it there for a couple of reasons. Number one, it fills up the drive and it makes the node unusable, which we have seen on a couple of occasions. Number two, that's not shared between the Windows VMs. So if you're on Win59 and you do a bunch of work and you go to Win60, that data won't be available. As far as the file system stuff goes, we are actively working to migrate off some older, less stable hardware that I'm sure for anybody who's used the Science Cloud, they've experienced file system issues or been with us when we have. We are planning that over the next few weeks. We'll make sure that we communicate that clearly to everyone well in advance. But we are moving to more stable hardware for the no backup and AT repo directories along with the home directories. That does not include CSS. And then I see a comment here, or the question, any chance of automatic weekly backups? So the no backup directories are not backed up. I believe we do have at some point some limited snapshot capability, but we try and discourage users from counting on that. If you need anything backed up, your best bet is to put it into your home directory. And then if you really need something backed up, probably just reach out with a support ticket, and we'll work with you to figure out what we can do there.
All right, that sounds good. Thanks, Jim. Okay. Well, I don't know. Okay, let's see. Home directory is only 10 gigabytes, but I think the no backup directory is much larger. Yeah, you can only put code in your home directory, and then you would have your outputs in your no backup space. But that's the way that's designed, is that your code is something you wouldn't want to lose, but you could always regenerate the data set since you have so much compute available. Okay.
Yeah, and I believe the default for your, sorry, Liz, the default for your no backup is, I believe, 5.5 terabytes. But then one of the other things we actually didn't mention, and honestly, I didn't even think about it until this question came up, was we have our own GitLab instance. So you could, in theory, and we do this with other projects like our NGA data ingest process, we actually manage our code through that GitLab instance, and we can access it from the Windows VMs, the Linux VMs. So that might actually be a better option if you're just worried about losing all the time you spent, writing code. You can get more information by submitting a support ticket, and we can get you access to that GitLab instance. It does work really well. We were able to, develop on our local laptops and then push it to GitLab, go into the Windows VMs or the Linux VMs, pull the code down, and it really is pretty nice once you get it all set up.
Okay, I'm not seeing other questions in the chat, but now's a great time. Any kind of questions if you're having trouble logging on or you can't remember how to do something, go ahead, you can ask it. Oh, here's one. Mark Chopping asks, are the G-Lite data for the above domain on the ASC? That's an interesting one, Mark. I'm not sure if they're not archived as part of above. I know that there's a plan for them to go to a DAC, but I don't know if they've made it there or not, because that was happening during COVID. So that's one I'm going to check into. If it's not there now, it would be good for us to get that data there. So I'll try to work on that one, because I think
Yeah, I think that
we want that.
Very good data set to have,
Yeah.
if it's not hidden away somewhere already.
Yeah, that's a good one.
Yeah,
Thanks.
yeah. I asked because we're trying to work with Bruce Cook, and we need all the data in the same place. So we're not downloading NGA data to our local machines. Obviously, we're trying to work in the cloud, which I think Darko's found a little frustrating for the reasons that you mentioned. But we're also working with the G-Lite imagery, so it will be great to have them both in the same place on the cloud. And then, of course, related to that is the issue of the Jupyter Hub that Darko could use, because I think he's not using it yet. Is that right, Darko? You're not actually using Prism yet.
No, I'm not. I haven't tested it yet.
Right. I think because it's been problematic in, as you described. But if there's a way that he can access it, that would be great. So one of my questions was international graduate students. That would, I guess it's a small minority of people perhaps, but they would really benefit from access to that system if they're working with machine learning, which Darko is. So, and he's getting some great results now. But we're trying to put everything together. It would be really helpful to have it in the same place. Thank you.
Yeah, I think getting the G-Lite there is a really good idea, and it's something that I know we were looking at before COVID, but I don't know if it's been fully archived yet at another NASA DAC, but we can work to pull that one back in. So I've got that on my list. And Darko, if you want to start using Jupyter Hub or Jupyter Hub notebooks, you can send me an email or you can email support, and we can work on figuring out how to get you access to that. So I think that'd be great.
Mark, let me ask, related to the G-Lite, do you mentioned imagery, and I wonder if you were also interested in their overlapping photography series, or are you just talking about the LiDAR?
No, I think it was the high resolution imagery that Darko was trying to use as validation.
Okay, yeah. It occurred to me, since you're talking about the NGA, that you might be talking about their photo series, which could also be used for DEM generation.
Right. No, we're not trying to generate DMs. We're just trying to validate our shrub mapping work.
Okay, I got it.
Okay.
Yeah. So Bruce actually approached us after the last science team meeting and said he'd like to work with us, and we jumped at that. But it's like I said, they're in different places. So G-Light's all stored on its own. Is it a Goddard site? I think. And then, like I said, they're in different places, so you have to grab it and do it on a case by case basis.
And
Which is
their system is really wonderful for like a subset of one specific spot, or for getting one of their flight lines. But if you want a comprehensive mapping of an area, it's actually kind of challenging to get it.
No, a location by location approach is fine, and I guess it can be done, without it being on the Science Cloud. But it just occurred to me the list of data sets that Liz showed us just now was just so huge. I couldn't scan it in time to see if G-Light was there, so I thought it would be interesting since they do. I thought maybe G-Light would be there, but I just hadn't seen it.
No,
So,
I think you're right. It's not there now that I know of, but I think it's something that we should pursue. So I will look into that.
How many locations Mark, are you talking about? Is it sort of is it a handful? Is it 50?
That's a very good question. We would like to have as many as possible. So we're still working on methods, would you believe, at this point. But we've made a lot of progress in that respect. And then soon we're going to want to broaden it out to a whole number of sites. So the number of sites that we actually end up covering was going to be in the hundreds, I think. But a much smaller number would be used for validation. So, and of course, it's restricted by what's available on NGA and where that matches up with the G-Light imagery. So
It just strikes me because the G-Light can be so voluminous.
Yeah.
Right. Yeah.
If you're talking about validating 25 locations,
Right.
it might actually be better to subset in the G-Light system, pull the validation locations and then put them into your science.
Right. I think we've done a little bit of that already, and I think that that approach certainly works. I just was wondering if it was on the above cloud, then it's sort of there. But again, it might not be subsettable in the same way that it is on the G-Light site. So
that's something that I guess Liz and
Jim, right?
Jim Shute might have to talk about.
Yeah.
Right.
It's
a big data set. So
having a browsable, interface on the Science Cloud for G-Light would be a whole nother thing.
Yeah, I understand that. It's probably quite a bit of work to integrate that. So for our purposes, probably it would be nice, but not necessary. But I just wondered if I'd missed it in that long list of that huge long list of data sets.
No, it's an excellent question. Liz will solve it.
Yeah. Hey, this is Laura, Liz. We did have some back in 2018. You guys were putting some G-Light data there, but I did want to make the point that if we're going to move data over, it would be great to actually put it on CSS rather than in people's no backup directories, et cetera, so that we set something up, set up a data management plan, set up a process for bringing this data in, whatever that process is, and having it somewhere where if somebody else comes along and asks the same question, we can at least say, well, here's what we have already, and we have a process. And so there's something that is already in place rather than having a lot of people just bring in the same data, or at least subsets of, and have it scattered all over the system. That's what CSS is intended for, is to have the ability to centralize all this data so we don't get duplication across user home directories and no backup directories. So absolutely, we should work on this. I also wanted to add with the Jupyter Hub piece, it sounds like Darko is actually doing machine learning and needs the GPUs, and that's fabulous. That's exactly what they're there for. If you don't already have the location, I don't think I have it. Yeah, I think I have it here. I'm going to pop this in our webpage. That'll give you some information. If you don't already have an account, that's the account request is there. The links to the Prism GPU cluster is there. And that should get you part of the way once everything's set up. So there's lots of compute there. They are being used, but there is still capacity. So we would love to have you on those systems doing really cool science.
Yeah, and I think if you want access to to Prism, it's probably you're going to be maybe talking with me or Natalie Sharp from our office, and we're going to give you access in the NASA identity system to some of the NCCS web service options, and then we'll work with NCCS. So I think some of their instructions maybe talk about going to the NASA identity system, but we do that part for you. So.
Oh, okay. Still, that the link I gave has all kinds of information
Okay, great.
as well. So yeah.
That's good. Okay, well, I think this was helpful. It was great to hear from everyone. And if there are more questions, you can pop them in, or you can pop them in the chat. I'm not seeing anything else. So I think we've gotten through everybody. So I appreciate you all coming, and I'm looking forward to seeing everything that you're doing. And yes, we will be making this recorded video available so that others can watch it as well. That will be up on our website in the next week or so. So thank you all for coming, and I really appreciate hearing from everyone. So we'll do another one of these soon.
Thank you.
All right.
Thanks, Liz.
Thanks much.
Thank you.